everyone, and a very warm welcome to all. I am Pritili. Today's topic of discussion: peaceful utilization of nuclear science. In the modern world, nuclear science is not only a source of energy, it also plays a vital role in medicine, agriculture, industry, environmental protection, and various areas of human welfare. To enlighten us on this important subject, we are honored to have with us a distinguished academician and researcher, Dr. Gita Purkayastha. Dr. Purkayastha has taught physics at the honors level of many years in several renowned colleges of Kolkata, including Leti Brabon College and Dinabandhu Andrews College. She has also made significant contributions to research. Several of her research papers have been published in prestigious national and international journals such as Physical Review and Nuclear Physics. She is a life member of the Indian Association for the Civilization of Science. Even after her retirement, she has remained actively involved in scientific studies and has also pursued research in biotechnology at the Indian Association for the Civilization of Science. Dr. Purkayastha has delivered talks on various scientific topics on Doordarshan and has participated in a long interview for the popular DD Bangla program, Ghore Baire. Now, with great respect and pleasure, I warmly invite Dr. Gita Purkayastha to deliver her valuable lecture. Thank you.
Hello everybody, I will start to speak today about peaceful utilization of nuclear science, and I will concentrate mostly on nuclear energy that is utilized for the generation of electricity, nuclear reactors, especially modern nuclear reactors, which are very useful for the generation of electricity and for other purposes, especially since 2020, thorium reactor is very much in the focus because it is less hazardous and thorium is used where thorium is available in India in large quantity. So my focus today will be on generation of electricity from nuclear energy, though I will try to say something more about other field also. Now, I must say a few words about nuclear energy and nuclear reaction. So, every material is consist of atoms. Atoms are electrically neutral particles containing central positively charged nucleus surrounded by an orbital electronics which are negatively charged, and the whole atom is electrically neutral. That means number of protons in the nucleus is same as the number of rotating electrons around the nucleus. Dimension of the atom is about 10 to the power minus 8 centimeter, whereas the dimension of the nucleus is about of the order of 10 to the power 13 centimeter. So you can imagine nucleus is very small compared to atom, and in this small space, nucleons, that is neutron and protons, are packed inside the nucleus, and they are packed inside the nucleus due to short range nuclear force, which is very high dimensional force, and therefore any reaction involving nucleus is from any reaction from nucleus involving nucleus, we can have large amount of energy. And now we'll explain how we can have energy from the nucleus. Now, nucleus have a certain mass. and represented by, say, nuclear name of the nucleus is X, is represented by X with superscript A and subscript J. What is A? A is the mass number and J is the charge number, and that is known as atomic number, and atomic number is responsible for the property of the nucleus. Our next goal is our next goal is what is nuclear energy and what is nuclear reaction. Now, as any reaction involving nucleus is responsible or a source of high energy. For example, if we split the nucleus, say uranium nucleus, by bombarding a neutron, it will split into two parts with generation of high energy. And that energy is in the form of heat energy, and which is utilized in the formation of, in the generation of electricity. Now, there are two main nuclear reactions which is responsible for the generation of heat, that is energy. One is nuclear fusion and another is nuclear fission. Nuclear fission is the great example of nuclear fission is our sun. We are getting heat and we are getting heat and light from the sun throughout the year, throughout the day, throughout the minutes, always. So how we get heat and light from sun? What is the source of it? The source is nuclear fission. What is nuclear fission? Two smaller particles, two lighter nucleus fuse into a heavier one with the generation with the liberation of large energy, that is heat energy. For example, if two deuterium atoms fuse into helium, a large amount of heat will generate, and that can be used for different purposes. Actually, hydrogen bomb is manufactured this way. Now, nuclear fission is not very much used for generation of electricity or any other purpose for peaceful utilization, because nuclear fusion is mainly used for the making of atom bomb. Now, other nuclear reaction, that is nuclear fission, is widely used for different purposes. Now, so we will concentrate mostly on nuclear fission. Now, what is nuclear fission? If some atom is bombarded by a projectile like neutron, it will split into two parts with a generation of energy and some other particle. For example, if uranium-235 is bombarded with thermal neutron, it will split up into two parts, bromine and krypton, with 3 first neutron and about 210 MeV of energy, which is in the form of heat, and that heat energy is utilized for the generation of electricity. I will elaborate this one. This is very useful process for the generation of electricity, and that is also clean electricity, clean energy. Now, how it is possible? The natural uranium contains two isotopes. One is uranium-238 and another is uranium-235. In natural source, percentage of uranium-238 is 99.2%, whereas share of uranium-235 is only 0.7%. And uranium-235, which is responsible for the fission, that is generation of heat. But in natural uranium, the role of part of the percentage of uranium-235 is very small. So what we have to do, we have to enrich the enrich the natural uranium source, that is increasing the percentage of uranium-235 so that we can continuously utilizing nuclear reaction, generate heat and ultimately electricity. So what is the picture? Natural uranium, which is known as the fuel, contain very small amount of uranium-235, so we have to enrich it. The enrichment process is very difficult and highly technical and expensive. Large centrifuge is used for the enrichment, and very few countries in the world can enrich the uranium. And the percentage of for civilian use, the percentage of enrichment is maximum up to 20%. But for the general nuclear fission, the enrichment is about 3 to 4%. And for military purpose, enrichment is more than 50%, so that this uranium can be used for making atom bomb or any nuclear weapons. For example, warheads for intercontinental ballistic missile. So we have now, suppose we are having enriched fuel, enriched uranium. So we will use say some amount of enriched uranium. We will bombard the uranium with thermal neutron, one thermal neutron. The uranium-238 will stay idle, will not take part, but uranium-235 component will break down, will split up into two parts with generation of heat about 210 MeV and in electrical unit, and 3 first neutron. This is known as nuclear fission. So for commercial purposes, for generating heat, large amount of heat for the generation of electricity, continuous reaction is necessary. That is known as chain reaction. How it is possible? Say one atom of uranium-235 is bombarded with thermal neutron. It will generate some heat and 3 more first neutrons. These 3 neutrons can split another 3 uranium atom. So we are getting 3 into 3, 9 neutron, first neutron. This 9 neutron can participate in the fission of another 9 uranium atom. So we are getting 27 first neutron. This is known as chain reaction. This can go on and on, but there are some special care, etc., and special, what should I say, special precaution we have to take. First, the first neutron are not capable of splitting uranium-235, so nucleon has to be slowed down, and this is slowed down by using a moderator. This moderator is generally heavy water, and if the neutron pass through heavy water, it will slow down and become thermal neutron. and the heat generated from the splitting of uranium-235 will be used for producing steam, and that steam will rotate the turbine and electricity will be generated. Therefore, this moderator, this is heavy water, it acts as both as a coolant, as a moderator, which slow down the neutron, and neutron become ready for next splitting of uranium-235 but the next fusion. Now this chain reaction will go on, and if it is not controlled, it will go on, and more and more and more and more energy will be generated, and ultimately there will be explosion. And this is the principle of atom bomb. But this reaction can be controlled by inserting control rods. That is by how we can insert boron or cadmium rod in the path of this neutron, so that some of the neutrons will be absorbed by the control rod and there will be sustained chain reaction. And this sustained chain reaction is known as criticality of the system. Now this whole system is known as the nuclear reactor. So what is nuclear reactor? In the nuclear reactor, there is in this connection, I must mention the name of our respectable Homi Bhabha. In the year 1950, he started India's nuclear program, and there is a first reactor is built in Bombay, is Apsara, and another is Kalapakkam, Kamini. These are the first reactor. And nowadays there are so many reactors in India. I will come to that point later. Now, what is reactor then? Reactor is specially built in such a way there is a dome-shaped structure, and inside the structure there is a source. There is source of fission, that is enriched uranium. Then there is moderator unit, which is heavy water. Normal water is H2O, heavy water is D2O. That is deuterated and oxygen combined to form heavy water. And there is control rods, and there is turbine, there is generator for generation of electricity. So according to our need, according to the quantity of electricity we want to generate, the energy, the reaction is controlled, energy is liberated in a controlled way. This is the principle of reactor. In this connection, I must give you some data. For example, for generating 1 watt of electricity, we must have 3 fission. We must have 3 into 10 to the 10 number of fission. And in 1 gram of enriched uranium contains 2.5 into 10 to the 21 number of fissile atoms, that is uranium-235. So you can imagine how much is electricity is generated from 1 gram of enriched uranium. And for each fission, each splitting, 210 MeV of energy is generated. Presently, about 10% of the electricity of the world is generated by nuclear fission, and India currently is producing 8 gigawatt of electricity from nuclear source. So this is the simple explanation of nuclear reactor, and this is a quite a old technology, and we are using it. But there is development, and today I will focus on the development of nuclear reactor and how these reactors nowadays used for generation of electricity without much hazard. Okay. In this connection, I must say few words about the nuclear hazard, because natural uranium contains uranium 238, and uranium 238 is not taking part in the fission. So, but uranium 238 is highly radioactive. So when the uranium 235 part is used up, uranium 238 part left behind, and this is known as spent fuel, and this is dangerous. So the problem now for the technologists, scientists, to dump the spent fuel, this is known as nuclear waste. This is also known as nuclear waste. In such a way, it will not contaminate the environment. It will not contaminate the plant, living bodies, etc. So it is a great hazard, and people or technologists should be very careful for dumping the spent fuel. Now, the more modern development is such that scientists and technologists are trying to avoid the hazard of spent fuel. How it is possible? Here comes the breeder reactor. And India is have very small source of uranium 235. Our uranium mining is very small and not very good quality. So we have to import uranium, and that is also enriched uranium. And so we have scientists this is not only for India, for so many countries it's the same problem. So since 2020, scientists are using thorium as a source of fuel, nuclear fuel for nuclear reactor for the generation of electricity. India is a very rich source of thorium. About 25% thorium is available in India, mainly on the beach of South India, Jharkhand, West Bengal, and Odisha. And this thorium is also very high quality. So there is constant effort and to use the thorium for generation of electricity, and thorium reactor is built. India, in Kalapakkam, South India, Chennai, there is a big project of breeder reactor. What is breeder reactor? Breeder reactor is three-phase nuclear reactor where thorium is used as a main source for nuclear reactor. Thorium is used as a fissile material for the fission. How it is done? Where three parts are there. The first part use the uranium source with usual pressurized heavy water moderator, and heat is generated, and electricity is generated out of that heat energy by producing steam and rotating turbine, etc., etc. This natural uranium contains both uranium 238 and 235. Now this 238 part is usually known as spent fuel or nuclear waste. But now this nuclear waste or spent fuel is used in the second part, where it is uranium-238 is bombarded with neutron, thermal neutron, plutonium is formed, and plutonium is fissile material. It will also split down and heat generated, and we get also we can produce in a usual way we can produce electricity. So this is the second part of the breeder reactor. Now, what is the third part? Third part is some of the plutonium which is formed out of uranium-238 is used in the third chamber, and it is covered with blanket of thorium. Blanket of thorium. So large quantity of thorium is covered. That is plutonium source is covered by thorium blanket. And here the moderator is not the heavy water, pressurized heavy water moderator. Here moderator is liquid sodium, molten sodium, molten metals coolant is used. Now what happens here? There is nuclear reaction. What kind of nuclear reaction? Thorium is not fissile material, but thorium is changed into uranium-233. This is another isotope of uranium, and that uranium-233 is fissile material. It will break down into two parts, and with a generation of heat and neutron, just as uranium-235. But here what is the utility and some advantage here? There is no hazard of spent fuel. We are not using natural uranium, where most part of the uranium is contained uranium-238, which is nuclear waste ultimately. But here the nuclear waste from the first phase is used in the second phase for generation of energy, and some plutonium is used for in the third phase, and covering this with thorium. And thorium is, with the reaction within few days, thorium is changed into uranium-233, which is fissile material, and molten metal moderator is used here for cooling and making the first neutron, or changing the first neutron to thermal neutron. That is, some energy of the neutron is absorbed here, and reaction is goes on. And we are having a large reserve of thorium, so we can use our own source of thorium for at least next 400 years. So if this is used as a commercial purpose, breeder reactor, we are saved. There is no hazard of nuclear waste or spent fuel, and no headache of acquiring uranium, enriched uranium from other countries. And that's why nowadays much more attention is paid on the reactor where fuel is used, thorium fuel is used for generation of electricity. That is reactor. Now we are coming to more modern part of the story. Now, especially China is now in the picture of thorium generator. No, sorry, not generator, sorry, thorium reactor. And they are building a huge thorium reactor in the Gobi Desert, where molten metal is used as a coolant and moderator. Generally, what is done for thorium reactor, one part of plutonium and 4 parts of thorium is mixed. Now, plutonium is end product of usual uranium, end product of uranium-38. How? If we bombard uranium-238, we can get plutonium. And that plutonium is mixed with, and actually we can get the plutonium from the nuclear waste, nuclear spent fuel. That plutonium is mixed with thorium, and thorium is gradually changed to uranium-233, which is another isotope of uranium, and which is used as a fuel for the reactor, and molten metal coolant is used as a moderator and coolant. So this is the modern way or modern wish of nuclear reactor. Here I must mention that there is some development in the reactor scenario. Nowadays, the scientists and technologists are erecting small and modular nuclear reactor using thorium as a fuel. And it is available commercially in some advanced country. And India is also now focusing on thorium reactor, because it is so our fuel is easy and it is less hazardous. As it is, there is no problem of spent fuel or nuclear waste, but one should be careful, because uranium 233, which is used as a fuel here, is radioactive. So we should take precautions so that there is no radioactive contamination or leaks, so that environment is polluted, etc., etc. And this micro or small reactor used for very specific purposes. For example, say you need energy. For example, you need energy for the manufacture of steel plant. So this energy we can get from nuclear source. How? We can build modular small reactor for generating electricity, which is needed for the smelting of, to produce steel. And this energy is completely, whatsoever, no carbon footprint is there. So it is carbon free energy. So steel produced with the help of this energy there is no carbon particle in the steel, and steel is very good quality. For different industry nowadays, small and modular thorium nuclear reactors are used. So this is the beauty of using thorium reactor for commercial purposes. India also now is very much study or the development of this thorium reactor, and of this thorium reactor. So I hope you can get a picture. You can get a picture of thorium reactor, and we are really very much fortunate having such a huge deposit of thorium And and our government is now interested in nuclear energy, because only with the nuclear energy and generation of electricity using nuclear energy, we can get clean energy, and our goal of 2070 less carbon print, we can achieve it. আচ্ছা, মীরা দেখো তো কিসের শব্দ হচ্ছে? মীরা, কিসের শব্দ হচ্ছে? অ্যাচিভ ইট কি হলো?
ম্যাডাম প্লিজ কন্টিনিউ।
আচ্ছা আচ্ছা আচ্ছা, ঠিক আছে, আমাকে না না ঠিক আছে, প্লিজ কন্টিনিউ বলছি। আচ্ছা ঠিক আছে, আচ্ছা ওকে। Thorium, India government is also interested in thorium reactor. But now, so I think I'm clear how our nuclear energy is utilized in the formation of, on the production of clean energy, and eventually generating electricity, so that our future goal of maintaining zero carbon footprint in the environment, we can achieve that goal. And another advantage of nuclear energy, utilization nuclear energy for electric generation, is it is all weather energy generation. It doesn't depend on cloudy weather or rain or heat or anything. It can be produced 24 hours a day, and like that. So it is very advantageous for us. Now I must give you some other uses of nuclear physics, nuclear energy. In our, as in the introduction, say refer to other fields like agriculture, medical, and industrial use. I must say a few words, and I must concentrate on this field also. So mainly, there is another property of nucleus. You know, as nuclear force is very high magnitude force, any reaction involving nucleus contain high energy. And some of the nucleus, some of the atoms or some of the materials are radioactive. What is radioactivity? They spontaneously emit alpha, beta, and gamma rays. What is alpha, beta, and gamma rays? Alpha ray is positive helium, stream of positive helium nucleus. What is beta? It is stream of negative particle or electron. And gamma ray is high energy electromagnetic wave. And these three electromagnetic ray contain high energy. Now, gamma ray, collimated and targeted gamma ray, is used for cancer treatment. Nowadays, there are so many other ways we can treat cancer, but still, nuclear radiation, that is gamma ray, is very much used for cancer treatment. Some familiar source of gamma ray for cancer treatment is cobalt-60 and cesium-137. And beta and gamma ray are used for different purposes. I will come to that later. Now, in medical use, medical science or medical treatment, nuclear energy is used. Another way of treating for medical use is diagnostic use. What is that? We can use nuclear trace element for detecting tumor or any other obstruction in our body. It is very common today, and so this is very useful use of nuclear energy for medical use. For agriculture, it is used in variety of ways. For example, it is used to disinfect the seeds for before sowing so that we can have good yield. We can mutate the seed, especially peanut and pulses are mutated with nuclear rays so that we can get good yield and better taste. It is also used for our waste management because nowadays there is a great problem of waste, not nuclear waste, any waste, and their daily life waste. And sometimes the waste also recycle also for good purpose or beneficial purpose. Now this waste is first treated with nuclear energy, nuclear radioactive rays, so that pathogens of the waste is killed by this treatment, and then it is modified. And after that it is modified or used in a specific way, whatever they use. And also in our space research in the manufacture of and the cryogenic engine, etc. The help of radioactivity and nuclear energy is very, very much beneficial. So we are really very fortunate. Our technologists and our scientists can reach the goal, and they can we can use this nuclear energy in so many beneficial way. And I hope in future there will be more and more ways and use of nuclear energy. The nuclear science will be beneficial to mankind. And so I hope with a positive note that we will have better world in future, and nuclear science will help to make this world much, much better. Thank you all.